So the CLO for today's lesson is that students will be able to graph and writing quadratics using standard form in the key features and the following language: if-then statements, standard form, quadratic, parabola, x-intercept, y-intercept, and vertex. So, in your own words, what do you think you're going to learn how to do in this lesson? So, to begin, let's start with all the vocabulary words. All right, so standard form is a quadratic form that looks like f of x equals ax squared plus bx plus c. So remember, quadratics, they are a specific function family where the biggest exponent is a 2. So the biggest exponent we have here is a 2. There can be smaller ones, like an exponent of 1, or this x has no exponent because there's no x. But the biggest one has to be 2. So whenever you graph a quadratic, if I come into Desmos and I turn on the graph for my quadratic x squared, it makes this kind of U shape. And it's always going to make this shape. Even if I were to, I don't know, add an x, I kind of moved it a little bit. Even if I added 20x, what happened? If I zoom out, oh look, it just still makes the shape. And then let's say I said minus 5, still makes that U shape. Even if I put a number in front of the x, like a 4, here I'll zoom in a little bit, scroll down. See how at the bottom it still makes this U-type shape? Let's say I put a negative in front. Let's see, let's zoom out. Up here, you see what happened? It's that U shape, but it kind of flipped upside down. So it's almost making like an N. Negatives in front do that. Negatives in front of the x squared specifically. So like if I got rid of everything and it was just negative x squared, I find where that graph went. Oh, look, it's right here. It just flips it upside down. See, no negative, it goes up. With a negative, it flips over. So negatives flip that shape over. So this shape that it's making, this U/N type shape, it's kind of like this curvy shape. It has a specific name, and that name is called a parabola. It's spelled parabola, but it's pronounced parabola, like this. Parabola. Parabola is how you pronounce it. And it's specifically the U or N shape, but it's specifically the type of N that's like flipped upside down like that. And it's the name of the shape. Just like, for example, this shape is called a circle. We don't call it an O. O is the letter, like the letter O is in the shape of a circle. So even though these look like U's and N's, we don't call them U and N when we talk about it properly. And when we talk about it properly, we call it the parabola shape. It's shaped like a parabola. That's what it's called. It's a parabola. So that's every time you graph a quadratic, no matter what, it's going to always look like a parabola, one of these two shapes. And then, so this is what we're working with. Quadratics, which are parabolas in standard form. But every graph we make, if we jump back to the CLO, it talks about how we're going to use standard form and key features. So key features is something that shows up in every graph, in every situation ever, not just quadratic situations. Even though we're learning about it with quadratic situations, key features can show up in any situation. So these are some of the key features. There's a lot more, but these are the ones we're going to focus on for quadratics. So we have x-intercepts. And x-intercepts, so intercept, like if you intercept the ball in sports, it means you catch it because you're crossing the path of the ball and you're grabbing it. So to intercept means to cross. So it's where the graph crosses the x-axis. And that's what makes it an x-intercept, is because it's crossing the x-axis. So a y-intercept would be where the graph crosses the y-axis. And then finally, vertex. So vertex with a quadratic specifically is the top or the bottom of the hump. So when it used like that, right where it switches, like where it humps, like right here or right here. So in this graph, this would be my vertex because it's at the top of the hump. But when it's the U shape and the parabola is facing upward like this, the vertex is still at the same place. Now it's just at the bottom of the hump. Easy way to think about it is the top or bottom of the hump. Remember, the hump is the parabola. However, the more mathematical way to think about the vertex, because vertex shows up in other equations, is vertex is maximums and minimums. So remember, maximum means the biggest point. And when I'm talking about the biggest, it's the biggest y, because it's the biggest amount. And so minimums is the smallest y, or the smallest amount. So if I were to look at this graph, the biggest amount, well, if I zoom up, you're going to see it's going to keep going up forever. It doesn't matter. Look, now this tick mark is 10,000. It's still going up and up and up and up. There's a point all the way up here. Like, it's going to keep going up forever and ever, but it's not going down forever. Do you see how there's no graph down here in the negatives? For this graph right now, the smallest points, the minimum amount is right here where the hump is. At the bottom of the hump, that's the minimum amount. Versus when it's flipped over like this and it's the top of the hump, then it's considered the maximum amount, because now the whole graph's beneath it, beneath that zero, all down here in the negatives. And there's no graph up here in the positives anymore. So when it's flipped like this, it's the vertex is the maximum amount, versus when it's flipped like that, the vertex is the minimum amount. So to clarify some words, when the graph is like this and it's pointed up towards the sky, it's called opening upwards. So when it's a positive x squared, the graph opens upward. Therefore, as the graph's opening upward, the vertex is considered the minimum because everything else is going up. So right now the vertex, the bottom of this hump, is the minimum amount. The vertex is the minimum. And it's important to note that when it's like this, there is no maximum. There's no maximum because the graph's going to just keep going up forever and ever. And then if it's a negative x squared, then the graph is facing downward because everything's going down. So I'm going to copy this. Except when it's a negative x squared, the graph opens downward. Therefore, the vertex isn't the minimum this time. The vertex, the top of the hump, is the maximum amount, meaning that there is no minimum in this case because the graph is going to keep going downwards. So these are the key features of any graph. So I have this example for us to do. I grabbed a graph, and we're going to identify all the key features. So we're going to start with x-intercepts. Remember that an x-intercept is where it crosses the x-axis. So the side-to-side one's the x-axis. And if you look closely, if I run my pen along this line, The green line is touching the x-axis right here, but it's not the only place because if I keep going along this black line, I see it also touches the x-axis right here. Here's the thing about parabolas. Because they make this U shape or the N shape, no matter what, it will always cross x twice because it's either going to go down, then go up, or if it's flipped over, it goes up, then goes down. But no matter what, it's going to hit the x-axis. If it has x-intercepts, it's hitting it twice. So there's an x-intercept right here. This point, when I write it, what comes first, the x or the y? The x is going to come first, and the x on this point is left backwards 2. It's at -2. Now the y, to plot this point, how far up or down does the point have to go? It doesn't go up and down. It's on the x-axis. For it to have a y, it would either have to be a point up here or a point down here for the y to be something other than 0. But since it's just staying on the x-axis, the y is 0. So that's one x-intercept. The other x-intercept is what? What's the x? 1. And what's the y? 0. The point is 1, 0 for this point right here. So those are the two x-intercepts. The y-intercept is where it crosses y. So where does the graph cross this up and down y-axis? If you look, it's crossing right here at -2. But to write this point, what's the x of that point? The x is 0. Because remember, x is how far left or right. And from this middle, I'm not going left or right. I'm just staying right there in the middle. But then my y is what? My y is -2 because then I'm going down 2 from the middle. And then there's my point. So that's my y-intercept. Then my vertex this time. So is this graph opening downwards or upwards? It's opening upwards, and if you scroll up, if it's opening upward, then the vertex is a minimum, which means the vertex right now is a minimum. It's at the bottom of the hump. And where's the minimum at? Well, this point, it's a decimal. And if I didn't highlight it and show you in the picture what it was, you would have had to guess what this decimal was. So here's the important thing about guessing this decimal. From the middle, this point, to get this point from the middle, if I look up, if I try to take a straight line up to the x part of it, to get there, I would have to go backwards. And if you look, this line's about halfway between 0 and the -1. And half in decimals is 0.5, which is why it's -0.5. And then this point, the y value, if I go over to where the y is right here for the point, like to get there, I would have had to have gone down 1, 2, and a little bit more. How much more? Well, it's not quite half. So if you guessed anything less than 0.5, so it's definitely -2. Then the point after that, if you guessed anything between 2.1 and 2.4, you would have been fine. But I highlighted the point, so we know it's 2.25. And so that's the vertex. So in any graph, you are expected to be able to pull out these things, the x-intercepts, the y-intercepts, and the vertex. You're also expected to be able to pull all of the key features out of a table. So to talk about how to find them in a table really fast, let's look at these x-intercepts. Do you see how for both x-intercepts, the y is 0? That's because if you're on the x-axis, if you're not moving off of this side-to-side line, that means you're not going up or down. You're only going side to side. So the x's can change because you're moving side to side, but the y's are going to always be 0. So that's part of the definition for x-intercept. If you go up here, you should add that for x-intercept, y equals 0 for all x-intercepts. So that means in my table for x-intercepts, we find where y equals 0. Then the concept's almost the same for a y-intercept. You see how the x is 0? It's because if it's a y-intercept, if it's on the y-axis, it's going to move up and down. The y's will change because it's moving up and down. But it's staying on that line, so it's not going to move left or right. Any points on the y-axis do not move left or right, so the x is 0. So that's part of the definition for the y-intercept, that for y-intercepts, x is always 0. So in a table, it's x being 0 that you're looking for. And then the vertex, here's the thing about quadratics. All quadratics always. They're symmetric, which means at the vertex, you see how like this line's cutting it in half right now, the y-intercept is? It cuts it in half perfectly, meaning if I go left 1, I'm down at -1 from the middle. But then from the middle, if I go right 1 whole tick mark, I'm down at -1 as well. It's going to always be the same on each side of the vertex. Like at -2, if I drop down to where the graph is, it's here at -4. But then if I go to +2 on the side of the vertex, it's also at -4. So it's always going to be the same on each side of the vertex. So in a table for the vertex is find the middle point. All other points should be symmetric on each side. So here's the thing, when I'm talking about the symmetry, it's specifically around the vertex. So like if I move where my vertex is, let's say this is my equation now. The vertex is right here at 5. So on the left side of 5, if I go over 1, now I'm at 4, and at 4 the y is -1. Then if 5's at my middle and I go over 1 to 6, and I go to where my graph is, it's also, 6 is also at -1. So it's really where the y's are the same, like the y's are symmetric around the vertex. So if I look here, here's 0, here's 10, here's 22, and then the next one's 10 again, which means this one right here, this is my middle point. This time it just happens to be in the middle, but it might not always be the one that's actually in the middle of the table. Like for example, I could have very much added these 2 points into this table, and still this is my middle points, because it goes, for the y's, it goes -40, -15, 0, 10, 22, and now back to 10. So this is where it goes back to one we already have. And then the next one is at 0, which means my next one, if I were to keep going, because the one before this 0 is -15, so the one after this 0 would also be -15 if I was to keep this table going and I was to add more points. And then the one after that would have been -40 because the one before this one's -40. So that's the thing about quadratics. So they're always symmetric around the vertex. So I'll write that down. Quadratics are always symmetric around the vertex. Meaning the vertex is in the middle, and then on each side, it's going to do the exact same thing. So in this case, we already talked about how this one, here's the vertex, because right before it's the 10, right after it's the 10, and it's going to keep the pattern on each side as you keep going. So to find the next key feature in here, I'm just going to go backwards, y-intercepts. I'm just looking for when x is 0. So x here is -9, -6, -3. Oh, here's where x is 0. So this point right here is the y-intercept. Instead of intercept, I'm just going to write int for intercept. It's like the short version. And then the other key feature is the x-intercept, which is where y equals 0. So I'm going to look at my y's. And remember, f of x just means y. It's just the fancy way to say y. So if I look, here's negative 40, negative 15. Oh, here's where y is 0. So here's an x-intercept. Again, I'm just going to write int for intercept. But remember, there's always two x-intercepts. So if I keep looking, here's y being 10, 22, 10, and here's 0 again. Because it's symmetric, it's always going to go back and hit 0 again, which is why you always have two x-intercepts. And so that's how you find them all in a table. So I'm going to explain why I taught you how to find all these in a second, because all these notes are about how to graph from standard form. So let's pretend I gave you this equation right here. And I was like, all right, graph it. Well, there's the long way of graphing. There's the long way of graphing where you just, because there's this rule in graphing where you always need at least usually 5 points to make a good graph. So I made space for 5 points. And when you start graphing the long way, you always want 0 to be like your x being 0 in the middle. And then you're going to go -1 and -2. And then after 0, you're going to do +1 and +2. Because what that does is it gives you x being 0, which is the y-intercept. And so you make sure you have your y-intercept in there. And then you do a couple negatives and a couple positives to figure out what's going on with the graph. And maybe you'll get a good picture, hopefully. So remember, to get the answer, what y equals, with this x, you have to take your equation. And instead of x, you're going to plug in what it tells you to plug in. So instead of this x here, I'm going to put -2. And instead of this x here, I'm also going to do parentheses -2. So then I'm going to take this and I'm going to throw it into a calculator. So it's -2 squared minus 2 times -2 minus 3. I put it into a calculator, I get out the answer of 5 equals 5. Instead of all the math in the box, I'm just going to put the answer. And then up here, I'll put all the math. So then if I put in -1 instead for the x's, so -1 here and here, I do that in my calculator, -1 here and here, I get out the answer of 0. Then I have to put 0 into both of them. So what if x is 0? My answer would be -3. What if my x is 1? My answer would be -4. And what if my x was 2? My answer would be -3. So here's all the points. Let's graph them and see if they make a pretty picture or not. So I'm going to do it in Desmos. So my x's went from -2, +2, and my point, this one was at 5. So if you look, they put this red point right here because from the middle, you go -2, left 2, and then up 5 to get that point. Then at -1, the answer is 0. So I went backwards 1, but the answer was 0, so it's right there. Then it's 0 with -3. I zoom out a little bit. Here's 0, -3. And then it was 1 with -4. So there's that one. And then here's 2 with -3, and so then here's this one. So if you think about connecting those dots, it sort of right here's the vertex. See where it U's out? So I'm like, wow, this is almost a pretty good picture. It actually has a lot of our key features in it. Like it has the vertex, it has the y-intercept where it crosses y, and it even has one of the x-intercepts. The only problem is it doesn't have the other x-intercept because there's always 2 x-intercepts. So if it were me and I was going the long way, I would just go 1 before this point and 1 after this point and test 1 on each side. So I would try -3, then I'd try +3. However, because I graphed it so far, I know it's not going to be the -3 one because -3, it's going to keep going up this way as it keeps going backwards. And what's going to happen is it's going to come over and it's going to touch it about here, which is probably around 3. So if I check it, if I do 3 squared minus 2 times +3 minus 3, look, I get out 0 when I plug in that 3. So in this case, when I plug in 3, I go out 0. And then, so I don't need to do this one because now I have all of my key features in my table, which means I'll have them in my graph when I graph them. Because this one's going to be 3, and then 0, and then look, there's my second x-intercept. And then I could connect my points and make a beautiful little graph. I could even include that point up there because it's going to keep going up anyway. So remember in the table, you can always make sure that you have all, before even graphing it, you can make sure that you have all of your key features. Because right here's the vertex. And we know that because before it's -3 and after it's -3. So it's symmetric on each side. This is an x-intercept. Because the y is 0. And then this is the other x-intercept. Because the y is 0. And look specifically how the x-intercepts are the same distance away from the vertex. Like this one's 2 boxes away going up, and this one's 2 boxes away going down. So because it's symmetric, the x-intercepts are always going to be the same number of boxes away from the vertex, or the same number of points away from it. And then finally, my y-intercept is where x is 0, so it's this one right here. So if my table has all 4 points I need, the 2 x-intercepts, the y-intercept, and the vertex, as long as it has those 4 points, then I can graph it and I know I have a good graph. But I need to have all 4 of these points. So what happens, because this graph, we were lucky that the ones we picked just so happened to be the key features. Watch if I change it to x and it connects all the dots. Ta-da! And the graph will just keep going up forever and ever. And that's why you can connect your dots once you have the 4 points you need to have. So sometimes it can be a lot harder. All right, let's say this is my equation. And I want to graph it now. And I'm like, all right, well, let's plug in -2. So instead of x, I'm going to put parentheses around it and plug in -2. Well, I get out 64. Put out -3 or -1. I get out 49. So I got to scroll out a lot to see the 2 points so far. They're up here. I put in 0 and I get out 36. I put in 1 and I get out 25. I put in 2 and I get out 16. So I've done this so far and I've only hit my y-intercept. I'm nowhere near knowing where it crosses my x's, nor knowing where my vertex is, like where it's going to hoop at. And so it's going to take me forever and ever to just keep picking x's. So I would have to keep trying to 3 and 4 and 5 to try to figure out where it is. And what happens if it ends up being decimals? Because that's possible. Here, let's put the x here and look at the whole picture. This is what it would eventually look like. So I would have had to have gone all the way over here to figure out those two x-intercepts and the vertex. So that's too much work, and there has to be a quicker way. And there is. So that's what I'm going to teach you. And I'm going to teach you the quicker way to find all of them from all of the forms. So this one specifically about standard form. So in standard form, to find the x-intercepts, remember x-intercepts, by definition, is where y equals 0, where the equation equals 0. So if I wanted to try to find the x-intercepts of this, and I wanted to say the equation equals 0, looking at this and thinking about the last unit, how would you solve for x? Well, if you remember, as long as it equals 0 and it's in standard form, to solve for the x, you use the quadratic formula. So in standard form, to find your two x-intercepts, you use the quadratic formula. And remember, when you use the quadratic formula, you end up with two answers, and then that's where you get your two x-intercepts from. The y-intercept is where x equals 0. So if you take the example equation, all you do is you make x equals 0, and then you put it in a calculator. So make x equals 0 and put it in a calculator. Here, instead of saying make x equals 0, write plug in. For all the x's, you'll plug in 0, and then you'll put it in a calculator, and that will give you the y-intercept. So for x-intercepts, when you use the quadratic formula, you're going to get two answers. So answer 1 is your x, comma, the y is going to be 0, because the whole thing equals 0. And your second answer is going to be the answer 2 you got, but then comma 0. Because it's an x-intercept, you always have to write it as a point with the comma 0 for the y part. And then with the y-intercept, when you plug in 0, your answer is going to be 0, because you're plugging in 0 for x, comma, whatever answer you get from the calculator. And so that's how you write the y-intercept as a point once you figure it out. Then the vertex comes in two parts. So for the x, you use a formula that looks like this. It's a fraction that's negative, and then whatever your b is, over 2 times whatever your a is. So then, to get the y value, you have to plug in the x value you found. And then put it in a calculator. So it's hard to imagine it as a point is that's the x value, comma, and then for the y value, you're going to plug in the x value. So we're going to practice all three of these on an example that we're going to graph together. So here's my example, and I want you to graph that equation. So I'm going to grab the how-tos for all of them. For the x-intercept, we're going to use the quadratic formula. So the quadratic formula is a negative b plus minus the square root b squared minus 4 times a times c, all getting divided by 2 times a. So in this case, a equals what? Negative 3. B equals what? Negative 11. And c equals what? Positive 4. I'm going to take the quadratic formula and plug in all of my parts. So b is negative 11, b is negative 11, a is negative 3, c is positive 4, And on the bottom, a is -3. So in the calculator, I have -11 being squared. That's going to be 121. So this -11 squared part can delete and become 121. Negative, negative in front will just become +11. -4 times -3 times +4. -4 times -3 times +4 is 48. +48, so I put a plus there. And on the bottom, 2 times -3 is -6. Now if I add 121 with 48, I would get 169. And if I take the square root of 169, I get 13. So the square root of 169 can be replaced with the fact that it's just 13. This is where I split it into two different answers. One that has 11 plus 13, again divided by -6. And the other one where you subtract them. So 11 plus 13 is going to become 24. 11 minus 13 is going to become -2. So when you put 24 divided by -6 into a calculator, you're going to get out -4. And when you put -2 divided by -6 into a calculator, you're going to get out positive 0.33333. So those are the two answers, but the x-intercepts always have to get written as points. So the 2 points are -4, comma 0, and 0.3333, comma 0. So we solve for the x-intercepts using the quadratic formula. For the y-intercept, I need to take the equation and plug in 0. So instead of x, I'm going to put parentheses around it and put a 0 there and put a 0 there. So if I come into Desmos, -3 times 0 getting squared, it's 11 times 0, 4. But look, the answer is 4. Because when you put 0 here, it becomes 0. When you put 0 here, it becomes 0. And you're just adding this last number. So in this case, because it's standard form, it's even faster than plugging in 0. It is just going to be 0, comma, whatever C is, whatever that last number is. Because when you put 0 into these two, they're just going to go away. So in this case, y-intercept is going to be 0, comma, 4. This one's really fast because you don't actually have to do any math. You can always just look at whatever that last number is for standard form. And then finally, to get the vertex. So this is the equation. And for the x value, it's to figure it out, it's -b over 2a. So x is going to equal what is b right now? -11. And it's going to be divided by 2 times a. And what is a? -3. If I do that math, -11 becomes +11. 2 times -3 is -6. And 11 divided by -6 is -1.8333. What a weird vertex. You would never have been able to figure that out with using the table. Because because it's a decimal x. Like, why would you guess a decimal x? So if you just try doing it the long way by plugging things into the table, like we did up here, it would have just not worked because you wouldn't have even figured out the vertex. So now I can take my equation to get the y and plug in that vertex, negative 1.833, negative 1.833. When I do that, it'll tell me what it equals, which will be my y value. And I get 14.083. The vertex, the x was negative 1.833, and the y is going to be at 14.083. So now that I have these points, so I'm going to grab them all and put them all close together. So now I need to make the graph. So if I had pretty graph paper, I could make a beautiful, perfect graph. But I don't have pretty graph paper in front of me. So I'm going to do an ugly by hand graph. So here's the important part. This y is 0, this y is 0, this y is 4, and this y is 14.83. So I need to make sure I go at least up to 14. So if I do one tick mark at a time, it feels like it's going to be too many. So I'm going to go by 2s. So I'm going to call this one 2, which would make this one being 4, 6, 8. Here I'll label 4, 6, 8. This one's 10, 12, 14. And ideally, they would be equal distance apart, like each little tick mark in my spacing. But I don't draw pretty, so they're not equal, which is why having graph paper is helpful because it can make it a perfect, pretty graph. So then on the x's, this is negative 4. This is 0.30, negative 1.8. So negative 4 is the biggest, so I'm going to go by 1s. So I'm going to call this negative 1. This one's going to be negative 2, negative 3, negative 4. And I'll make this one positive 1. So now, if I were to put points on my graph, here, I have to label this x, label this y. And then if I were to place my 4 points on my graph, I have to estimate as best as possible. So negative 4 0 is going to be right here because it's left 4, but it's not going up or down. 0.33 is a less than half between 0 and 1 because it's not a whole 1 yet. So it's about there. 0, comma 4. So when x is 0, y is up here at 4. So that's my y-intercept. And then finally, my vertex is at negative 1.8. So it's almost negative 2, but not quite. And then positive 14. So then I'm going to go up to positive 14 plus a little more because of that little decimal. That would be my vertex. And then when I connect my graph, remember it hoops at the vertex. So this is where I'm going to curve down on the left side and then also curve down on the right side, trying to connect all my points as pretty as possible. So that's me trying to do it by hand. If I was perfect, and these were x's, this is what it should look like. Your y-intercept right there. Here's an x-intercept, another x-intercept, and your vertex up here. And then it is perfect on each side of it. It makes a beautiful little parabola shape. And so that's the quick way to graph from standard form. The quick way to find all 4 points, and then graph them and connect them and make a pretty picture.